So in previous class, we have learned about the gradient of least square lost in a linear model. So hope you that you are aware of those things. And this class, we will be learning about a new concept that is related to tensors. So before moving on to the tensors, just we can see one example, that is gradient of vectors with respect to matrices. So that is first, we have learned about the gradient of vector valued function. Then related to some linear model, we have learned the gradient. And now what we are going to learn? Gradient of vector with respect to the matrices. So for that, we are considering the following example, like f is equal to ax and f belongs to r real number and dimension is m. Okay, m is the dimension of that function f. Since it is a matrix. Okay, that is a here, f is equal to ax, a here it indicates a matrix and x indicates a vector. So the function will be like it belongs to some real numbers of dimension m, and a will be a matrix, that is it belongs to m by n, m rows and n columns, and x will be belonging to Rn, that is real numbers with n values. It becomes a vector. And here we need to find, as usual, we need to find the df with respect to dA. So that what will be the in linear model also, we first found the dimension of that derivative. So when you are computing this df by dA, what is the dimension? F in the dimension is m, isn't it? It belongs to Rm, so f dimension is m, and then a dimension is m by n. So m by n. So the df by dA, it belongs to a set of real numbers of dimension with the dimension m by n. So this is the dimension of the dimension of the gradient df by dA. Now we know that gradient is the collection of partial derivatives. So df by dA, you can write it like df by dA with respect to dA. Okay, del f1 by del a, etc. del fm by del a. So it will be having, function will be like, it will be having some functions which you will be taking derivative with respect to this x variable. X variables. Okay, a is a matrix and mx is the vector. Df1 by del f1 by del a, etc. up to del fm by del a. So this how many number of functions you will be taking the derivative based on the number of rows of the matrix A. So del f5 by del a belongs to the real number r. So f will be like it is belonging to the number of rows, isn't it? Okay, here the number of del f1 by del f1 to del fm, it depends on the dimension of this f. Okay, dimension of f will depend ചെയ്താണ് നമുക്ക് matrix derive ചെയ്തെടുക്കുന്നത്. Okay, derivative it ranges from del f1 to del fm. How? With based on the dimension of f. So dimension of f, it is given like f element of Rm. So based on that, we are having values from del f1 to del fm. Okay. So del f5 by del a, it belongs to set of real numbers. That is 1 by m by n. Why here it is given as 1 by m by n del f5. So at a time, a single function will be calculated. For del f1 by del a, it will be getting the value as 1. Okay, del f2 by del a, it will be resulting in a single value. That is why it is given as 1 over here. Okay, for 1 by m by n. Then partial derivatives in case of this is a matrix multiplication, isn't it? So in order to get the partial derivative for this vector multiplication, you can make use of this formula, that is Fi is equal to sigma j is equal to 1 to n aij xj. So this principle you see, then you will be able to find the derivative of f with respect to a. So with this summation, we can take the derivative of Fi with respect to ai will be equal to x cube. Okay, അപ്പം summation എടുക്കുന്ന f is equal to ax ആണ്. അപ്പോൾ when you are taking the derivative of f with respect to a means it will be resulting in a value x. അപ്പോൾ അവിടെ ജനറലൈസ് ചെയ്താണ് ഇവിടെ പറഞ്ഞിട്ടുള്ളത് del fi by del ai cube. Okay, ai cube will be equal to x cube. So how you have taken this? Based on this, first you will be taking this matrix multiplication form. Based on this matrix multiplication form, you will be able to write the partial derivative in this format. Del fi by del ai cube is equal to x cube. Okay, you will be getting a single value with respect to that x. For row wise, you will be able to take. This allows us to compute the partial derivative of Fi with respect to row of A, which is given as del Fi by del I, which is equal to x transpose. So here you will be getting one x value and transpose you will be taking in order to get the derivative del Fi by del A. Okay, so xt it will be belonging to set of real numbers 1 by 1 by n. So del fi by del ai, f will be an element that belongs to set of real numbers with a dimension m. A എന്ന് പറയുന്നത് it belongs to the set of real numbers with a dimension m by n. So here you are taking a single function. Okay, ഒരു സിംഗിൾ ഫംഗ്ഷൻ എടുക്കുന്നു, അതേപോലെ ഒരു സിംഗിൾ റോ ആണ് എടുക്കുന്നത്. അപ്പോൾ based on that single function and row, it will be resulting in a value that is x and its dimension will be 1 by 1 by n. അപ്പോൾ ഈ n എന്ന് പറയുന്നത് എവിടെ നിന്നാണ് കിട്ടിയ? Based on the dimension of x. Okay. അപ്പോൾ x എന്ന് പറയുന്നത് it belongs to set of real numbers that having n number of elements. Okay, അപ്പോൾ അതിന്റെ dimension എന്ന് പറയുന്നത് Rn. അപ്പോൾ അത് ബേസ് ചെയ്താണ് you will be getting the x transpose. So ഇനിയിപ്പം del fi by del ai എന്നല്ലേ നോക്കിയത്. അപ്പോൾ ഇനി ഈ I ന്യൂമറേറ്ററിലും ഡിനോമിനേറ്ററിലും സെയിം ആയിട്ടുള്ള എലമെന്റ്സ് വന്നില്ല എന്നുണ്ടെങ്കിൽ, if other than this I, the other entries it will be taken as if it is considered means it will be taken as 0. അതിനാണ് ഈ ഇക്വേഷൻ യൂസ് ചെയ്യുന്നത്. del fi by del ak which is not equal to y, that is ന്യൂമറേറ്ററുമായിട്ട് it doesn't match, then the other entries can be made as 0, resulting into the dimension 1 by 1. Same dimension തന്നെ ആയിരിക്കും, പക്ഷേ entry will be like it will be 0. Okay. Then in order to find the gradient, what we need to do, we need to combine all the derivatives. അപ്പോൾ ഇവിടെ derivatives എന്ന് പറയുന്നത് എന്താണ്? del f1 by del a, del fm etc. up to del fm by del a. അപ്പോൾ ഓരോ ഡെറിവേറ്റീവ് കണ്ടുപിടിച്ചതിന് ശേഷം അതെല്ലാം you need to combine it together to get what? The gradient of that matrix. Gradient of the vector with respect to that matrix. So you will be getting the result like this. Okay. അപ്പോൾ del fi by del a with respect to some element, it will be getting as a 0 transpose. Like that it goes on. അപ്പോൾ അതിന് കറസ്പോണ്ടിങ് ആയിട്ട് വരുന്ന വാല്യൂസിന് മാത്രം, ന്യൂമറേറ്ററിന് കറസ്പോണ്ടിങ് ആയിട്ട് വരുന്ന വാല്യൂസിന് മാത്രം you will be getting the value as x. ബാക്കിയെല്ലാം will be filled as 0. and that results in the dimension R belongs to 1 by m by. Okay, so just go through that and see whether you are able to understand. We can continue in next class.